Okay, this is section 9.10, which is energy for life. And energy for life is section 8.9 in your textbook. Very short section. It's important to know this, though. If you're going to have any type of food is a chemical, and chemicals undergo chemical reactions. So, for instance, let's take sugar. If I were to take sugar and set it on fire, and oxygen, if there's oxygen in the room, it will burn very hot and very fast. So you get a big high flame, and in a few seconds it would turn into black carbon ash. Okay? If you eat that same teaspoon of sugar, the same amount of energy that was in that fire on the lab table is the same amount of energy that you're getting out of the sugar. You're not getting it at a high temperature. You're getting it out at your body temperature. It takes much longer to do it, but you're getting the same amount. So that energy came from the sugar, just like burning the sugar. Well, if it got hot, then it must have lost energy. Well, if it got hot out on the lab table burning, then the energy that would have gone into fire on the lab table went into your cells to provide energy for you. Okay, so what's happening is the chemicals have bonds between them. All the elements are bonded in a chemical. And if you want a new chemical, if you want to break apart that chemical, think of it like Legos. They break apart and then they reconfigure into something new. So if you have sugar, which is C6H12O6, carbon, hydrogen, oxygen, 6, 12, and 6, there's lots of energy in those bonds. If you break those bonds, okay, now you need oxygen, so you need oxygen O2 to come back in, so C6H12O6 plus O2, what are you going to get as a result? Okay, at the end of that chemical reaction, you're going to get carbon dioxide gas, CO2, and water, H2O. There's very little energy in those bonds. There's lots of energy in the bonds of the reactants at the beginning. There's very little energy in the bonds of the products at the end. The rest of that energy went out into your cells and was stored inside your cells, normally as fat, and then that fat turns into sugar. The sugar then can feed your cells when it needs it. So the energy is higher at the beginning, lower at the end, and that is what's required for life. Now, green plants do something exactly opposite. They take carbon dioxide and water. Now, if you remember those, that was what you do when you burn sugar in your body. You make carbon dioxide and water. Green plants take carbon dioxide and water in the presence of sunlight, which is a high energy, radiant form of energy, and the specialized organelles inside that plant cell is able to turn the sunlight's energy, trap the sunlight's energy by taking the low energy molecules of water and carbon dioxide and turning it into a high energy molecule of sugar. So a plant like an apple will essentially eat the sun, turn it into sugar, and that's why an apple is sweet. And then when you eat the apple, you can take that sugar and turn it back into carbon dioxide and water and get the energy that was put in by the sun. So the sun is the ultimate energy source for all life on Earth, whether it be animal life, human life, or plant life. So what role does energy play in sustaining life? Well, you have to have energy in the form of chemicals that we call food. And if it's more energy at the beginning than at the end, then that energy can go in to sustain life.